We're about to start on page 29, which is on solving rational equations. But before we get to solving rational equations, I'd like to just look at a linear equation first. Okay, and we did review linear equations on Friday, but I'd like to look at a linear equation that perhaps involves some fractions. Okay, so let's just perhaps look at something like this. Okay, I don't know, I'm making this up on the spot, so let's go with 2/3 x minus 3/4 equals 1/6 x plus 1/12. Okay, and again, I completely just made that up. Okay, so find somewhere to write this down. It can be somewhere on a piece of paper or somewhere, I don't know, in the margins of your booklet. Find a space. Now let's first establish, is this a linear equation? Is this linear? Yeah, why is it linear? Yeah. Yeah, there's just an x with like degree 1, right? Yes, the coefficients of x have these fractions in front of them, but there's no x squared, there's no square root of x, there's no x in the denominator, so this is in fact linear. Okay? Now last week we talked about how when we're in this situation, we should start to take steps to collect our x terms on one side of the equation and our variable terms on the other, our numbers on the other side of the equal sign. I'm getting distracted by the noise in the hall. Let's just close the door. Okay, so we talked about collecting our x terms or our variable terms on one side of the equal sign and our numbers on the other side of the equal sign. Okay, now in this case though, it's not so nice to deal with fractions. Okay, and because we're dealing with an equation, with equality, we have the luxury of being able to multiply the entire equation by something that would actually eliminate all of the denominators. Okay, because in an equation, all we're really concerned with is preserving the equality. As long as the equal sign is happy and the left side equals the right side, we're good, right? We ultimately want to do something that's productive, that's going to isolate the variable, but really we just need to make sure mathematically that we're preserving the equality, and then everything's okay. Okay, so let's say we did want to do that, and we wanted to multiply the entire equation by something that would eliminate all of the denominators. What do you think we could multiply everything in this equation by that would eliminate all of these denominators? We've got the denominators 3, 4, 6, and 12. What could we multiply everything by that would take care of all of them? What do you think? Yeah.
I'm not sure, but they all have 12 as a factor.
Yeah, well, not 12 as a factor, but 12 as a multiple. Yeah, if we multiplied them all by 12, then all of the denominators would cancel. And 12 is, in fact, the least common denominator between all of these denominators. Okay, so what I'm going to do is I am going to multiply the entire thing, every single term, by 12. And I'm going to multiply it by 12 over 1. And I don't have to multiply it by 12 over 12 here, because I am allowed to multiply everything by 12 as long as I do it to everything and preserve the equality. Okay? It's not like an expression where I have to multiply it by 1. Here I can multiply everything by 12 because if I do, that equal sign is still balanced. The right side still equals the left side. Okay, well now what happens now is we multiply our fractions together. Here we're going to get 12 times 2 is 24 over 3. X minus 3 times 12 is 36 over 4 times 1 is 4 equals 12 times 1 is 12 over 6x plus 12 times 1 is 12 over 1 times 12 is 12. Okay, and now if we look at what's left, well, all of these fractions actually simplify to whole numbers. And so 24 over 3 is 8x minus 36 over 4 is 9 equals 12 over 6 is 2x plus 12 over 12 is 1. And now we're not dealing with an equation that has fractions anymore. We're dealing with an equation that has everything as whole numbers. Okay, and this is much easier to solve. We don't have to deal with any fraction operations. Okay, so we could take our steps to collect all our x's to one side. Perhaps maybe we'll bring our x's to the left side, so I'll subtract 2x from both sides. And then maybe I'll bring my numbers to the right side, so I'll add add 9 to both sides. Getting ahead of myself here, right? And then the 9's on the left side cancel, so 8x minus 2x is 6x. And on the right side, 2x minus 2x is 0, so those cancel. 1 plus 9 is 10. And then I can divide by 6. And the 6's cancel, and I end up with x equals 10 over 6 reduces to 5 over 3. Okay. Now this is essentially the process that we're going to go through when we solve these rational equations. Okay? We're not going to want to deal with these denominators. And so what we're going to do is we're going to multiply our rational equations by the least common denominator. And what will happen is that we won't have denominators anymore. Okay, so that's kind of an overview of the process. Big picture with numbers. All right, so on to rational equations. Well, a rational equation is any equation that includes a rational expression. Okay? Okay. Now, the way that we are going to solve these is essentially by multiplying the entire thing by an LCD. Okay. And what's going to happen is that we're going to be transforming these rational equations into either a linear or a quadratic equation, which is why we reviewed those last week. Okay. Now, what happens when we do that is we actually change the nature of the equation. It's no longer rational anymore. It's linear or quadratic. Okay. Now, the complication with that is that a linear or quadratic equation does not have non-permissible values, and a rational equation does. And so that's something that once we get to an answer, we're going to have to go back and think about. Okay, so that's one thing that we're going to see today. Okay, so to solve, we transform into a linear or quadratic equation by multiplying the entire equation by the LCD. Okay. Now, this may produce answers that are okay for a linear or quadratic equation, but are not okay for the rational equation, because in the rational equation, they would be non-permissible values. And those types of answers are called extraneous. And so if we come across one of those, we actually have to throw it out. Okay? If we get an answer to the quadratic or linear that is a non-permissible value of the rational, it's called extraneous. And we throw it out. And we'll see examples of this. Okay, so just in terms of what's considered acceptable and what's considered standard of excellence, according to the curriculum, acceptable is something that ends up being a linear equation, and standard of excellence is something that ends up being a quadratic equation. Okay? All right, so let's start out looking at some of these. All right, determine the solution to the equation. Do you guys need more time to write this down? Okay, I'll leave the last little point up. Okay. Determine the solution to the equation 3 over x plus 3 equals 9 over 4x plus 7. Okay, well, the first few steps to solving rational equations are the same as what we would do with any other rational expression. Anything else involving rational expressions. In this particular problem, we don't actually have to worry about the first one, but in general, you would always start out by factoring everything. And state your non-permissibles. Okay, well, we could state our non-permissibles here for sure. Okay. These are factored, though. We don't have to worry about the factoring piece. That's done for us. Okay, so let's look at our first denominator, x plus 3. What non-permissible is that going to produce? -3. So x cannot equal -3. What about the second one, 4x plus 7? What's the non-permissible going to be from that one? The Or would you have to do a little bit of work to figure it out? Yeah, right? So some of you might be able to do that in your head, but whenever the coefficient of x is not 1, if you're not sure exactly what it is right away, just set the whole factor, 4x plus 7, not equal to 0, and then solve it as you would any other linear equation, right? So if we like subtracted 7 from both sides, you're going to get 4x cannot equal -7, and then divide by 4. Right, so there's your other one. X cannot equal -7 over 4. Okay? Now the third thing that we're going to do is we're going to identify the LCD and multiply everything in the equation by the LCD. Okay, so in this case, I've got one factor is x plus 3, and the other factor is 4x plus 7. What's the LCD there? Do they have any common, is there any commonality between those two factors? Is there any commonality there? One of them's x plus 3, the other one's 4x plus 7. Anything in common between those two factors? Yeah. Okay, but remember, once something's factored, has to be identical. That's one factor. That's the other factor. Are those identical? No. So they both have to go into the LCD. Okay? So the LCD in this case, if the factors are not identical, is x plus 3 times 4x plus 7. Okay? So I'm going to now spread yourself out. Give yourself some room. 3 over x plus 3 equals 9 over 4x plus 7. Okay, so I'm going to multiply this side by x plus 3 times 4x plus 7. And I'm going to multiply this side by x plus 3 times 4x plus 7. Okay. Now what's going to happen is that the denominators will cancel. Okay, so on the left side, which factor is going to cancel? The x plus 3's, right? So this cancels. What am I left with? What's left? What's left over? What haven't I canceled? 3 times 4x plus 7. Okay. On the right side, what cancels? The 4x plus 7's. What's left? The 9 times x plus 3. Okay, so that's good. We've done that step. Step 4. Well, what we've done in that step is we've transformed this equation. It's no longer rational. Now it's linear. And so in step 4, we've got to solve the resulting linear equation. In this case, it's linear, but it might be quadratic. Okay, so step 4 is to solve the resulting either linear or quadratic equation. Okay, so here what we need to do is like expand. So we're going to go 3 times 4x and 3 times 7, so that's going to give us 12x plus 21 equals, and then 9 times x is 9x plus 9 times 3 is 27. Yeah? Okay, so we'll talk about cross multiplication. Yeah, I get that question a lot. I'll address that in a moment. Okay, thanks for asking though. I'm glad you asked that. Okay, and now we have to collect x's on one side and numbers on the other. Was anyone else thinking about cross multiplication, by the way? No? Okay. All right, so maybe I'll like subtract 9x from both sides. If you had cross multiplied though, you would have still ended up with this line, right? Yeah. And then I'll subtract 21. So I'm collecting numbers on one side. This is like my x side. And this is my number side. Right? Here's all my equal signs. Okay. And so this is gone, and I get 3x equals, this is gone, and I get 6. So divide by 3, and I get x equals 2. Okay, kind of hard to see the division line. There we go. Okay, so we get our answer. And the very last thing you need to do is you need to, in step 5, what do you think you need to do here, actually? We've got our answer. I kind of addressed this a little bit in the introduction. So look above when I started talking a little bit about rational equations. Do you think, like, in this case, actually this situation is okay, but sometimes it's not. What do you think we might need to check here in step 5? We've got to check something. We've just solved a linear equation. We've transformed, yeah. Yeah, we've got to check to make sure that this answer isn't an extraneous solution. Yeah, because if this happened to be one of our non-permissible values, we'd have to throw it out and say that this equation has no solution. Okay, so check for extraneous solutions. Okay, so back to the question about cross multiplication. Okay. Now, the question is, why can't you cross multiply? Well, in this case, you can cross multiply. Here's the thing, though. Cross multiplication is actually just multiplying by the least common denominator. That's what it is. Okay. When you cross multiply, you're not multiplying one side by 4 plus 7x, or sorry, 4x plus 7, and the other side by x plus 3. What you're doing is you're multiplying both sides by x plus 3 and 4x plus 7, x plus 3 and 4x plus 7. And what happens is that certain factors cancel. Okay? And so in this case, sure, you could take that shortcut. Okay? The reason why I hesitate to encourage that is that that shortcut only works when you have an equation where you have a fraction equals a fraction. If you have any other type of equation, for example, rational expression equals rational expression plus rational expression, you cannot rely on cross multiplication. You have got to do it this way, multiply by the least common denominator. And we're going to see questions like that tomorrow. Okay? And so you've got to be versatile in your strategies. If you are comfortable doing it this way when you need to, and you'd like to take the shortcut of cross multiplication when you see that you can, that's fine. As long as when you come across a question where you can't cross multiply, you know what to do. Okay? But cross multiplication is just multiplying by the least common denominator. That's what you're doing. Okay? So that's what I'll say about cross multiplication. Okay? And in fact, on that note, I actually want to do the next question both ways. I want to do this one using cross multiplication and by multiplying by the LCD, because some interesting things happen when we do it both ways. Okay? And the reason why I want to do it both ways is because I see students do it both ways. So let's see what happens. So firstly, the first thing we always do is factor and state non-permissibles. Okay? So is there anything here that we can factor in this question? Can anything be factored? Yeah, what can we factor? Yeah, the 2x minus 4. So how could we factor the 2x minus 4? GCF of 2, right? So this, I'm going to write it above, because otherwise I'm going to run out of room, because the smartboard I have to write kind of big. But 1 over x minus 2 equals 3 over 2 times x minus 2. Okay, so if I'm now looking at, I did my factoring, now I'm looking at my non-permissible values. Okay, so my non-permissible values here are, okay, what can x not equal? X cannot equal 2. Okay. All right, so which strategy do you guys want to do first? Do you want to do cross multiplication, or do you want to do multiplying by the least common denominator? Yep. Where do you see the 0?
Oh, never mind, sorry.
Yeah, so this is just a 2. It's not, if it was 2x, then yes, there would be a 0. Yeah. Okay, so which do you guys want to do first? Do you want to do cross multiplication or multiplying by the LCD? Cross multiplication? Okay, so let's say we cross multiply. If we were to cross multiply, this is not my favorite way of doing things, but okay, I will indulge you guys. Let's say we started from there. And let's say we hadn't factored, okay? Well, then this would come up here, and this would go up there, okay? So we'd get 1 times 2x minus 4 equals 3 times x minus 2. Yes? Does that make sense? Okay. So we end up with here, okay, 2x minus 4 equals 3x, and then we've got to distribute, so 3x minus 6. Okay. And so now if we collect our x's on one side, let's say I collect my x's on the left. So maybe I'll like subtract 3x from both sides. Okay, which means I need to bring my numbers to the right side, so I'll add 4 to both sides. And I end up with 2x minus 3x is what? Negative x equals negative 6 plus 4, negative 2. Okay, so what does x equal? X equals 2. Okay. All right, let's do it the other way. So if we multiply by the LCD, what is the LCD here? Okay, so I've got to have that factor of x plus 2, x minus 2 in there, right? Okay, so I've got x minus 2. Now if I look at my other denominator, that's 2 times x minus 2. Am I missing any factors? Just the 2, yeah. So it's just that. Okay, I'm just missing the 2. I'm not missing the x minus 2. So I'm going to start here. Equals 3 over 2 times x minus 2. And on both sides, I'm going to multiply by 2 times x minus 2 times 2 times x minus 2. Okay? And on the left side, just the x minus 2's cancel, correct? Yeah? Does that make sense? Okay. So what am I left with? What am I left with on the left? 2 times 1, which is 2. Okay. On the right side, everything cancels, right? So the 2's cancel, and the x minus 2's cancel, and what am I left with? 3. Huh. That's interesting. 2 equals 3. Okay, so let's take a look at this. When I cross multiply, I get an answer of x equals 2. When I multiply by the LCD, I get this nonsensical thing that says 2 equals 3. What's going on here? Yeah. Yeah, I stopped early when I cross multiplied. I stopped early. I got an answer to the linear equation without checking to see if it was extraneous, right? This, x equals 2, is a non-permissible value. So what that means is that there's no solution. Whereas when I multiply by the LCD, I get something that doesn't make sense, which also tells me there's no solution. Okay, so here, extraneous, no solution. Okay, this is nonsensical, which means there is no solution. Okay, so you actually end up with the same answer, but it looks actually quite different depending on what approach you take. Yep?
So we can take either approach as long as we remember that if the answer to the cross multiply is one of the NPVs.
Correct. In this case, you can take either approach. Once and I don't know if we'll have time, let's see. We might have time today. Yeah, I don't know if we'll have time today. We might. We'll see. We might get to it today, but definitely tomorrow we'll be looking at some examples where we can't, we don't have the option of multiplying by the LCD, or by cross multiplying, I mean, okay? And so in general, that's not what I like to model, just because it doesn't work for all examples. And what I see is that when I model that, people don't know how to address the other type. Okay? All right, so here's another one. Determine the solution to the equation x minus 2 over 2x equals 1 over x minus 3. Okay, well, so the first thing that we would have to do here is factor. Do we need to factor anything? No, that's done. Okay, good. LCD. Oh, maybe I'll do non-permissibles first. Okay, so I'm looking at my denominators. One of them is 2x. What non-permissible am I going to get from there? 0, yeah. And then the x minus 3? 3. Yeah. Okay, what's my LCD? One of my denominators is 2x, so that's got to go in there. The other one's x minus 3. Are those identical? They're both factored. Are they identical? No. They both have to go in there. Okay? So I'm going to multiply the equation by that. I'm definitely going to run out of room here. Okay, so x minus 2 over 2x equals 1 over x minus 3. And I'll multiply by 2x times x minus 3. And on this side, times 2x times x minus 3. Okay, and then stuff cancels. So my 2x's cancel on the left. And on the right, my x minus 3's cancel. And yeah, with this one, if you wanted to cross multiply, you could too, because you have the fraction equals the fraction. Okay, so what we're left with is x minus 3 times x minus 2 equals 2x. All right, what do you think we need to do now? It's no longer a rational equation. What do you think we should do now? Yeah. How would you combine like terms at this point? Yeah. Yeah, multiply these out, right? We're multiplying these two binomials together, so we've got to expand, right? So we're going to go x times x, and we get x squared. And x times negative 2, and we get minus 2x. And then we can move on to the distribution of the negative 3. So negative 3 times x, and we get minus 3x. And then negative 3 times negative 2, and we get plus 6. Okay, and that equals 2x. Okay, and now, yeah, I would combine like terms, right? So the negative 2x minus 3x, those are like. So I can go x squared, and then negative 2 minus 3, it's negative 5, so minus 5x plus 6 equals 2x. Okay, so what type of an equation is this one? Quadratic. Okay, so we've got to solve a quadratic equation now. All right, so what do we need to do here to solve the quadratic equation? Yeah. Yeah, we got to equate one side to 0, right? Okay, so we're going to subtract 2x from both sides. Okay, and I actually need to move over here because I'm running out of space. So on the left side, x squared, and then negative 5x minus 2x is minus 7x plus 6 equals 0. Okay, now what? Now what can we do? We've equated one side to 0. Yeah. Yeah, now we can use the quadratic formula. Okay. Some of you actually might be able to factor this one. If you can factor it, go for it. But of course, in this course, you can absolutely use the quadratic formula, and that's what I'm going to model. Okay. So we've got A, B, and C. Okay, A is the coefficient of x squared, and what is that? 1, B, negative 7, and C, 6. Okay, and our quadratic formula, this is on your formula sheet. X equals minus B, plus or minus the square root of B squared, minus 4AC, all over 2A. All right, it's a bit of a mouthful. Okay, and when you're subbing, I highly, highly recommend, I've said this before, sub in brackets first instead of actual numbers. So you have x equals minus bracket plus or minus the square root of bracket squared minus 4 bracket bracket all over 2 bracket. Okay, and then you can plug stuff into the brackets, and then you're less likely to make sign errors. right? Especially important when, like if A, B, and C are all positive values, it's not as big a deal. But when you've got one or two of them being negative, or three of them, this is more important, okay? So I'll plug in a -7 for B. And then A is 1, C is 6, and 2A is 1. Okay, and we'll start with the radical part. So -7 all squared minus 4 times 1 times 6. So let's figure out how much is that. -7 squared, maybe do it off to the side. Right, you could do that on your calculator. Just make sure you put the brackets in as you see them, if you want to. What is that? You guys all have calculators in front of you. Yeah, 25, yeah. So -7 all squared is 49, and this is 24. So this works out to be 25. Okay, so -7 is just 7 plus or minus the square root of 25 over 2. Okay, so we're going to get square root of 25 is 5. So we're going to get x equals 7 plus 5 over 2. Or x equals 7 minus 5 over 2. Okay, and 7 plus 5 over 2 is 12 over 2, which is 6. Okay, 7 minus 5 is 2. So this is, I'm running out of space here, but 2 over 2, which is 1. So there's your two answers. X equals 6 or x equals 1. Okay, so what should we do at this stage now that we've got our answers? It's the last step. Yep. Check for extraneous roots. Yeah, and what were our non-permissibles? They're hiding here in the corner. 0 and 3, so these guys are both fine. Okay? Okay, so what I'd like you guys to do is work on questions 1 on this page, and then 2 and 3 on the next page, and I'm going to give you guys about 20 minutes to work on those, and then we will discuss as a group. Okay?